Hey Astrodevs, welcome back to another video from Astrodevs channel. In this video, I'm actually starting a new playlist which is called Astro Lab. In Astro Lab, we are actually going to have some different type of videos, which first are solving code challenges from various websites. I'm actually going to start the series with a question from LeetCode, but if you have a question and you want to see us try and solving it, you can leave that in the comment section. Or if there is any other website that you love and you love the question and you think those questions would be also fun to solve and make a video of it, you can actually leave them in the comment section down below. And if you don't know any of these coding challenge website, I actually have made a video about them which is shown above. You can use that card to watch the video. But also what we're going to do in this playlist is a kind of video that is about debugging the code and reviewing the code. For example, you have made a repository and you think your code is kind of messed up. So you want us to go and check your code and we can see if we can make your code any better. We can find some flaws, about the speed, memory, or any other things, or maybe you have an issue in your algorithm or some of that, use your imagination. And also those kind of videos are going to be assigned to us from you guys in the comments below, and so you can share the repository if it's your own or someone else's. You can share the repository and ask us, let's go and check the code out, see how good it is, or see if you can modify it to be any better. And also me personally, when I'm coding the projects that are assigned to me from the company or my own projects at Astrodevs, I come across tons of problems, and they need critical thinking. They need you to think like an engineer. They need you to think like a machine. And I was thinking that I can make a video of them too. I can start a video saying, hey Astrodevs, I was coding, I came across this problem, and here is how we want to solve it, and let's see if we can solve it. Or maybe I have solved it already and I'm just going to try and teach you how it should be solved, or what is my solution, and ask you guys what's your solution for this kind of problem. So these were the three type of video I want to make for this playlist. But also I'm actually making another playlist which we are going to share our daily lives as devs, and I will tell you, for example, about my daily routine or about the mindset. Maybe for example there is a kind of solution in your life, you cannot set up your task, you cannot finish your project. I will tell you about the methods that I have tested and applied in my own life, and those have worked for me. And I will tell you, give a try to this one, because I'm a dev and you're a dev, so something that has already worked for me might work for you as well, right? Anyway, let's start the coding. So as you can see, I'm on LeetCode. You can just come to the website using the link leetcode.com. And when you're here, you might not see this page over here. You actually need to sign in, and after you sign in, this is now your main page over here. You can go to the Explore tab, which has tons of different question collections, which you can see, for example, about data structure and algorithms, system design, LeetCode for beginners, I don't know, top interviewing questions, and also question packs from big companies. You can see Google, Facebook, Microsoft, Amazon, Apple, and these are all authentic questions. These are actual questions from Microsoft, Facebook, or these other big companies. But these are locked and they need you to pay for a premium plan. I actually don't have a premium plan, but if you want to work for any of these companies, or if you are actually curious, you want to know how Google asks questions, you want to know how Facebook asks questions, you can actually go and pay for them. This is not a sponsored video, but I'm just trying to show you every feature that this website has. What I need you to do is to go to Problems tab, and in there go for Study Plan. And in Study Plan, you can see some featured collections. The one that we want to start solving is Top Interview 150 Questions, Must-Do List for Interview Prep. And you can see we have different categories: array string, hash map, matrix, intervals, and so on and so forth. We are going to start by solving every easy question from different categories. So what I mean by that is we are going to solve every easy question from the array string, from 2 pointers, sliding window doesn't have any easy question, matrix as well. But for example, the hash map, we're going to solve every easy question from hash maps, interval, stack. And when we finish every easy question in here, we're going to start by solving every medium question. and we go and solve every medium question, and we start by solving every hard question, and we finish the whole thing. But as I said, it doesn't mean that the next video we are going to be solving remove element question. No, you can actually ask us to go and try to solve from another website. Maybe you have a favorite website, for example from Code Wars, and you want us to solve a question from Code Wars, or you have a specific question that you don't know how to solve, or you want to see our solution for that. So you can, comment that down below, and we go surely check that out. Your comments are our top priority, so don't mistake that if we are going to just be going in this order. Anyway, what I'm also going to do in the series, I'm actually going to try to do in the series, is tell you how to behave in an interview. I know some of you guys just want to solve this out of curiosity, but I know some of you guys as well who are aiming for an interview and want a good and practical interview prep. So what I'm actually trying to do is to use my experience from prior interview sessions and tell you how you can behave, or how you can even ask a question. Like, if you don't know what does nums1 mean, you can ask it, because you need to understand the solution. Because you need to understand the question before trying to solve it. I actually zoomed in a little bit so it's more visible for you guys. Anyway, yeah, that's what I'm saying. I'm going to tell you how you can think in an interview. Most of the companies, they just don't throw you in an interview session. They firstly do a normal interview session where they ask you about your previous works, about your resume, or where do you live, for example, what is your favorite color and such of that. And when you have passed that, the next step is going to be a coding interview most of the times. And it might be an online session, or they might assign you a task and tell you have 1 week to solve the task, and they grade you for your work. But as well, you have something as a live coding interview where you are on site, you are in the company, or as I said, it's an online interview, and they give you a task, they give you a question about, for example, like this, and they want you to solve the question. But most of the time, it's not about if you can solve the question or not. They actually want to see you in action. They want to see you how you can think, or if you can think like a machine. Like for a certain question, there might be 100 solutions, but only some of them are practical and applicable in a coding environment. So they want actually to see you in action. For example, see you what you do when you face a bug, what you do when your code doesn't work, how you try to solve it, how can you address the bug or the solution. So change your language to Dart. I actually will try to go and use, for example, JavaScript, Java, C++, or even C. My friend who is also in Astrodevs does Python, so you might actually see us solving some problems with Python. But most of the time I'm going to use Dart because I have a lot of videos about Dart and Flutter. I actually have a 5.5 hour Dart masterclass, which you can find it using the card above. Anyway, let's read the question. This is an easy question, and you're actually going to know about 2 pointers. I'm actually going to tell you about that. I will try my best to lecture that topic for you. Anyway, merge sorted arrays. You are given 2 integer arrays, nums1 and nums2, as you can see over here, sorted in non-decreasing order. What does non-decreasing order mean? It means you might have 1, 2, 3. You weren't going to have 3, 1, 2, 2, or for example, let's say 10, 2, or 6, 4, something like that. No, it is in a non-decreasing order, meaning you might even face, for example, something like 1, 10, or 100, or for example, 1, 3, or 5, but you're never going to see 3, 4, or 1, for example, 2, and then for example 4 again. You're not going to see anything like that. It's a non-decreasing order. It is always going up. And 2 integers, m and n, you can see them over here as well, representing number of elements in nums1 and nums2 respectively. So this n is for nums2 and m is for nums1. Merge nums1 and nums2 into a single array sorted in non-decreasing order as well. So after the merge happens, we all need to keep that order untouched. It says the final sorted array should not be returned by the function. So you can see the function returns nothing. It's a void function over here, but instead be sorted inside the array nums1. So what we are actually doing here is to merge nums2 into nums1. We are not going to making a new list. We don't need it. We just need to merge nums2 with nums1, keeping that order, that non-decreasing order. To accommodate this, nums1 has a length of m plus n. So m, as it said here, does not represent the length of nums1. It's just the number of elements. The real length of nums1 is m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums has a length of n. So for nums2, n is both the number of elements and the length of it. But for nums1, you can see it over here. Nums1 over here has 6 elements, right? 1, 2, 3, 4, 5, 6. And the length is 6, right? So how you can calculate that? You can just say m plus n, which is equal to 6. Then that is the length of nums1. But you have some elements that should be ignored, which are the last n elements. So the last 3 elements, which are 0 and 0 and 0, should be ignored. So these zeros are not for comparison. These should not be in the final merge. These should be ignored, and you can think of them as kind of a placeholder for the final list, which is going to be merged with the nums1. So we should ignore these last n elements, but we need to keep these first 3 elements, which are 1, 2, and 3. And you can see, nums2 is 2, 5, 6, and the output is 1, 2, 2, 3, 5, 6, which is in a non-decreasing order. The explanation says the arrays we are merging are 1, 2, 3, and 2, 5, 6. You can see these zeros are ignored. The result of the merge is 1, 2, 2, 3, 5, 6 with the underlying elements coming from nums2. So this one comes from here, this 2 comes from here, this 2 comes from the nums2, and this 3 comes from here, and 5, 6 come from nums2 as well. Example 2. Input is the nums1, which has only 1 in it, and we have only m, which is equal to 1, but the nums2 is an empty list. So an empty list means n is 0. So we should ignore nothing from nums2, and we can just return nums1 itself, because the arrays we are merging are 1 and an empty list. So the result of merge is just 1 itself, because there's nothing to be merged, right? But we have another edge case, which is if the nums1 has a 0 in it, but the m is equal to 0, meaning there is no elements that we are going to keep from nums1, and this should be ignored because n is equal to 1. So meaning only one element is in nums1, and that element is going to be ignored, and in nums2 we have 1. So the result of the merge is just a list that has 1 in it. The explanation says the arrays we are merging are an empty list and a list with 1. The result of the merge is just a list with 1 in it. Note that because m is 0, there are no elements in nums1. The 0 is only there to ensure the merge result can fit in nums1. So that's just to keep everything neat. You can see the constraints over here. So it says nums1 that length is equal to m plus n, nums2 length is equal to n, m and n are always greater or equal to 0 and less than or equal to 200, and m plus n is always equal or greater than 1 or smaller or less than or equal to 200. And this is the range for your list, as you can see it over here. Anyway, it says, can you come up with an algorithm that runs in O m plus n time? Yes, we are going to try it. Anyway, I'm going to tell you about these time complexities later, but let's see if we can solve it. So what I'm going to do here is to use 2 pointers. What I mean by 2 pointers, let me give you a theory solution. So let's say we have a writing pointer, which is equal, and it starts from the end of our nums1 list, which if I want to point to here, I need to say m plus n, that's the length of the list, but I should say decrease it by 1. Why I should do that, for those who don't know? Because m plus n is 6, alright? But 6 is not inside this. Why? Because we start counting the index from 0. So 0, 1, 2, 3, 4, 5. So you can see the 6 is out of the boundary of the list. So I need to say, and I need to point to the last member of this list by saying n plus n minus 1, which is equal to 5 in this case. So 5 is this. So the fifth index is 0, 1, 2, 3, 4, and 5, which is this one, right? So this is my writing pointer. This is where I want to start writing, right? Anyway, I can have a nums1 reading pointer, which actually does point to the last element from nums1, which, as you can tell, is m minus 1. Again, for the same logic, if I just say m, 3 is 0. I don't want the 0. I should ignore it. I should start counting from here. I should start pointing from here. So I say m minus 1, and I can have another thing similar to nums1 reading pointer, which is nums2 reading pointer, and again I use the m to point to the last member of the list. Anyway, what we are going to do is to create a loop, a while loop, and we go on and we check every member. So let's say first up, our nums1 RP is going to be equal to 3, right? And our nums2 reading pointer is going to be equal to 6, right? So what we say is the reading pointer is going to be equal to the number of this condition. What condition? We're going to say check if the number that nums1 reading pointer is pointing at is bigger than the number that the nums2 reading pointer is pointing. Then this is a simple inline condition. I don't know the actual term, but I call it an inline condition. So nums1 RP return the nums1 RP from here. Or if, let's say, the nums1 RP was not bigger than nums2 RP, so we return nums2 RP. So what happens here is, this is our condition. So whatever is in the left side of the question mark is your condition. We check that. And this is our true case. If this was true, do this and return this. And this is our false case. If this was false, then do this. So what we say is our writing pointer is equal either to this if this was bigger, or to this if this was bigger. So we are actually getting the biggest number of this comparison, right? And we also need to move through the list. So after each of this, we're going to decrease writing pointer by 1. We're going to decrease nums1 reading pointer by 1. And also we're going to decrease nums2 reading pointer by 1. But this is going to happen through each run. But we are actually going to decrease nums1 reading pointer by 1 if we write this, or if we write this. So it's actually going to look like something like this. So we say if you wrote this, decrease this by 1, or if we wrote this, decrease that one by 1. And that's actually how we go through the loop and through the list. So let me uncomment these because these are correct. And we just need to define the type. These are all going to be an integer. This is going to be an int. All right, I need my while loop. And in my while loop, I'm going to say until nums1 RP is greater or equal to 0. And also until nums2 RP is greater than or equal to 0, right? So we want our while loop to go and iterate through each of those members. So what I say now is I go say nums1, where the writing pointer is pointing at, is equal to the same code we wrote. nums1, where the nums1 reading pointer is pointing at, if it was bigger than the number that the nums2 reading pointer is pointing at. Come here, check that, and if that was bigger, so we write nums1 reading pointer. This is the index. It is holding the index of that specific number. So that's how we access that number. By saying this, it actually returns, for example, 3 to us. If I just write this, it is going to, I don't know, saying 2, you can see. Anyway, and if it wasn't bigger, so we write nums2 reading pointer's number. But as I said, we need to decrease this by 1, so I just say it minus minus. What happens here is we first collect whatever the current value is stored inside here and return it. And after that process is done, we just decrease it by 1. If it was something similar to this, what would happen is we first decrease it by 1 and then pass it. Okay, so we don't want that. We first want the actual current value, and then if the value is passed, come here and decrease it by 1. And also what happens here, if we decide to write this, we need to decrease it by 1, or if we decide to write this, we need to decrease this one by 1. This code works, but has a flaw. Let's find that. Oh, sorry for the semicolon. Alright, don't panic, it was just a semicolon error. Alright, let's see. You can see 2 of our test cases were passed, only 1 is not. Let's see what happened. Alright, this is code true, output is 1 2 3 5 6. Yes, this is true, you know, one of the edge cases where the m was 1 but n was equal to 0, but we just returned the same thing. But in here what happened was m was 0 but n had a value, so we needed the merge, but what we were giving and what we were storing was actually the incorrect value. So let me tell you what happened here. You see, in case 2, although that n was 0, and when we saved it like this, we actually made it to be -1. So because 0 minus 1 is equal to -1, and that made it so this loop will actually be never run because one of its condition is false, right? So it actually was helpful because we skipped this whole thing and we didn't do anything to nums1, which wasn't necessary because we just needed to return whatever was inside nums1 because n is 0, you know. So when n is 0 and the nums1 should be our final list, so n is 0, there is nothing to merge into nums1, so that means we just can, you know, leave anything aside and just return whatever was inside the nums1 from start. But that actually made this case to fail. Why? Because m was 0, right? So by saying m minus 1, we actually made the nums1 reading pointer to be -1, and actually that made this condition to be false and this code to never run. But that's a flaw. Why? Because we had some values inside nums2 list which should have been merged. Anyway, so we need another loop which does that for us. In here, we only check nums2 reading pointer and we say check if it has no value in it, if it is greater than 0. If there was some value, come here and write whatever is inside in the same going order into nums1 and nums2 rp minus. And that actually makes sure that even if our nums1 was just an empty list, as you can see, but had placeholders, and those placeholders should have been filled by whatever value is inside nums2, we make sure that this code does that for us. And if I run the code, you actually have 2 options. You have run, which runs these 2 test cases over here. You can actually add to them, but you know, these 2 examples over here, it actually runs them. And you have a submit, which actually goes through a lot of test cases, sometimes over 500 test cases or close to that. But you can see every case has passed and it's accepted, so we can submit our code. And what happens in the end is yeah, you can see it has a study plan, don't remind me later. And you can see the Astrodevs has beat 100% of competitors in runtime and 50% in memory. Yes, this code actually is a bit messy memory wise, but it's good. 100%, 50% is good. Sometimes you face 100% and 5%. That's bad. You need to work on your code. Or sometimes, for example, you will see 80% write time and 80% memory. That's actually fine. You don't need to have both of them 100%, because, for example, if you're going to go for runtime, you're actually going to be heavy on the memory. Or if you're going to have a less memory usage, your runtime might be a bit longer. But it says 0 millisecond. I don't know how the code will run, but you can see 59 test cases pass. So that was our first video. Tell me what you think about it, or tell me if you have any other kind of solution for this. As I said, don't forget to tell us about other websites if you want us to go and solve questions from those said websites. And also make sure to subscribe to our channel, follow us on our every social media. And one thing that I will ask you is help us to grow money for our next project, which you can donate money to us using Buy Me a Coffee website and our profile. You can find a link in the description down below. Always, thank you guys for watching, and see you in the next video.